Cool. Hi. So we're gonna talk about coordinators today. Let's get the boring stuff out of the way first. All right, cool. We have a little lag. Boring stuff. This is my Twitter handle. I only tweet about my blog posts and my podcast. My friend Krista Zombach and I also started a podcast about a year ago, and we get really in depth on technical things. We found there was like a lack of technical podcast content. And for good reason, because it's impossible to talk about code just using your voice. But we try every week. And so that's our podcast. But I think if you're here because you know me because of my blog. I try to write as much as I can. I spent 2015, I wrote almost every week. And this was one of the first posts. This was in January 2015. And it was just called The Coordinator. And I kind of laid out kind of the basics of this idea. Some of you may have heard of it. Some of you may not have. We'll go into a lot more depth. But yeah, I laid out the basics of the idea. And the dirty secret was I had never actually used a coordinator when I wrote this post. I was just it was all very theoretical. And then I made an app later that summer, and I was off to NS Spain, and they wanted to talk, and I thought I would talk about the coordinator pattern like in practice. So I wrote this much more in-depth article on my blog, and this is sort of the blog post version of the talk that you're sort of about to see here. So what is a coordinator? What problems do they solve, right? So the big one, I think, when you are first starting out with iOS app development, the very first architectural problem that you run into is this, right? You just put everything in your AppDelegate. You can kind of access it from anywhere because it's just kind of global, and you can just put all the crap in there, and then you can always get to it, and it's great. And you know that something is wrong, and you want to fix this, and this is like the first problem that you want to try to fix. And so what does this AppDelegate end up doing? It ends up initializing your database stack. It ends up maybe initializing any networking stuff that needs to be set up, setting up your analytics libraries. It ends up setting up your root view controller. If it's a tab bar, it's setting up all the children for the root view controller. It's doing all of that stuff. And so let's take this example of view controller configuration for starters, right? So you get a little bit smart. Once you've done this once or twice, you're like, you know what? I'm not going to put in the AppDelegate this time. I'm going to subclass UI tab bar controller, make my own tab bar controller, and I'll stick all the code in view.did-load or whatever. And this kind of it works, but it doesn't really feel like it's the right place to put this code either. You're kind of making a subclass just to put this stuff somewhere. But you don't really have a proper home for it. So I think that app bootstrap, that app initialization, we still have bootstrap code in the talk previous, needs a place to live. And neither the subclassed UI tab bar controller, which really isn't supposed to be subclassed, or the AppDelegate are really the right place to put that code. So that's the first problem that coordinators help solve. The second problem that they help solve is the sort of responsibility problem. When you're working with view controllers, they end up getting really big. They end up getting, 1,000, 2,000, 3,000 lines of code. I've seen a 5,000 line view controller. There's some hairy stuff out there. And the reason is because it does a lot of things, right? So these are some of the examples that we're going to look at. There are other things besides this that it does. Model view binding, right? Taking your model and applying it to the labels and the image views and everything in your app. Creating and holding on the subviews that it's going to need. Fetching data. Laying out those subviews, transforming the data from the model to the sort of final form that it's going to be in, handling navigation flow, handling user input, mutating the model, which by model mutation here I mean posting to an API, writing to your database, something like that. And so it has all these responsibilities, and they don't have none of these things have a good place to go, and so they just end up bloating your view controllers until they get huge, and you're like, well, this sucks, and how do I solve this problem? And I think part of the root of this is the idea of MVC, the idea of model view controller. I think the name controller is really bad. I for a long time I've always thought just it ends up being the catch-all. There's a quote by Graham Lee. I'm gonna put on the screen. This, I think, really nails down the problem, right? He says, when you get overly attached to MVC, then you look at every class you create and ask the question, is this a model, a view, or a controller? Because this question makes no sense, the answer doesn't either. Anything that isn't evidently data or evidently graphics gets lumped into the amorphous controller collection, which eventually sucks your entire code base into its innards like a black hole collapsing under its own weight. I think this quote is really nice. It really expresses the problem cleanly. Like all of those things that we looked at earlier, all these things, if we don't, as they're not evidently model data and they're not evidently graphical data, so they can't go in either of those places, so they just end up in our view controllers. So this like these view controllers are overwhelmed, and like we need to kind of address that problem. So I think that's kind of the second kind of architectural thing that you run into when you're working in iOS, and we're going to address like where these things go in just a moment. So if you look at the original formulation of model view controller back in the Smalltalk 80 days, there were lots and lots of these triplets all over your like application or whatever. And if you notice, like the controller and the model talk to each other, right? And the controller and the view talk to each other, but there's also this line here. And for me personally, this line makes me very uncomfortable, and I know a lot of other people, this line makes them uncomfortable. Models and views are not supposed to directly touch the way that we are like classically taught model view controllers. So what we do, I think, is better named something more like model view adapter, where the adapter sits in between the model and the view and makes sure that they are separate enough to where they can be reused, and these adapters are the sort of the thin glue that connects everything together. These verbs are commonly used for describing the changes that flow back and forth between these two, but more or less in iOS, this is what we have, right? We have model, view controller, and a view. So yeah, if you don't really pay attention to what's happening here and what's happening here, this gets really big. And on top of that, there are things that just don't belong in any of these places. So where do you put them, right? When you're looking at like a network request object, is that a model, of view controller, or a view? Well, it's a kind of a model, but not really. Or like an NS operation, what is that? Where does that go? An NS operation queue, where does that go? If you have a player object, let's say your app plays audio, and you want to put a player object, which one of those is that? It doesn't hold on to these things. The things that we write don't fit into these buckets very cleanly. And so kind of one of the things we want to address is that. So the third thing that I think coordinators help solve is this snippet of code. And this snippet of code is everywhere. It's in Apple's like default templates. It's all over the place. And it's really, really deeply flawed. And if you step through it line by line, you kind of see why it's so flawed, right? So this first line is not that big of a deal, right? We get an object at an index path. The data source is sort of the logical child of the view controller. And so not a big deal. That's fine. Like this is how objects are supposed to work. They talk to their children. Then this line is where things start getting a little weird, right? You're creating the next view controller in the chain. You know how it needs to be initialized. That means if there's any dependency injection, you're going to know about that. That means if there's any special details about like, oh, on this platform such as iPad, I need to do this, but on this platform, iPhone, I need to do that. That's all baked into how you're deciding what this next view controller's like configuration is going to be. And this last line is where things go totally off the rails, right? You're basically grabbing onto your parent, your navigation controller, because remember the parent view controller and the navigation controller are the same, and you're giving it a very specific message about how to do the next step. They say in, so like, yeah, right, cool, yes, okay. In programming, yeah, my bad, sorry. This is a child. It is telling its parent what to do, right? In the real world, we definitely don't want our children telling our parents what to do. And in programming, we ideally don't even want our children to know who their parents even are, right? So, yeah. Let's look at like kind of another concrete example of this problem. If you had a very popular photo sharing app, you might have a flow like this. You have a view controller where you pick the photo either with the camera or from the camera roll. Then you straighten the photo in another view controller, you filter it in another view controller, and then you kind of caption it in the last view controller. This is the one that's presented, and this is the one that's dismissed. This view controller knows that it's being dismissed even though it had no concept of being presented in the first place. Like, why does it know that it's the one that needs to be dismissed? And the problem lies in all of these. They all kind of know only about the next step, and there's no place in the app that this whole flow lives. It's separated among all these objects. It's hard to follow. It's hard to track. So there's this other thing that I really like. Yeah, so it's this idea of frameworks versus libraries, right? So the concept is that frameworks call you, and you call libraries, right? And I ideally want everything I work with to fit more in this category than in this category. Like I want to be in control of the way that the code that I work with is working, right? I want to be in control of like how UIKit works. Like I want to tell UIKit what to do rather than waiting around for UIKit to call me back and say, hey, like now you're allowed to do some work. Like it's view did load, like now you can do some stuff. I want to turn view UIKit on its head and control it. So how does the coordinator fit into all of this? In the same way that a view is kind of transparent to a view controller, like a view controller controls this view, it knows everything about it, it sends it specific messages about what to do. It's, its child. And you can take that even a step further. The view has a child of its own, the CA layer, to which it's transparent, and the view sends commands to the CA layer to tell it what to do. I want to add something that's above all of that, and that something is the coordinator. So in this setup, the view controller is going to be transparent to the coordinator in the same way that the view is transparent to the view controller. Yeah, and there's also a nice little elegance here in that like there's a tree of CA layers, right? Every layer has an array of sublayers, and so that makes a tree. Every view has an array of subviews, so that makes another tree. Every view controller has an array of child view controllers. And as we'll get to in a little bit, you're going to have child view controllers as well to kind of take some of those flows, separate them, make them reusable, and work with them that way. So, yeah. So I think there's a nice little balance there. Everything starts from the app coordinator, right? This solves that first problem of like, where do I set up my app? Like, what's in charge of like making this whole show run? The app coordinator is usually held onto by the AppDelegate and sets up those initial view controllers. Presents them, gives them the dependencies that they need to start working if you use dependency injection. In other texts, this is sometimes called the application controller. This is a good book, Patterns of Enterprise Application Architecture. It's kind of like a cookbook for a framework kind of like Rails, but it has a lot of interesting patterns that you can kind of bring back and bring to your own code in the mobile world. So yeah, their application controller handles like a flow broadly. Yes? The book, yeah, it's called Patterns of Enterprise Application Architecture by Fowler. Yeah, Fowler. It's a good one. You read through it and you're like, David Hannemeyer Hansen literally read this and copied it to make Rails. Like, it is like the patterns in it are just straight out of there. But there's good stuff in there. I recommend reading it. They call it an application controller, which represents sort of the flow through the application. In this case, I call it a coordinator. So we got to talk about like what responsibilities does a coordinator take from the view controller, right? So we had this thing from earlier. We got some sections now. We got a section for the model, a section for the view, and a section up there for the coordinator. So we're going to go through these and like kind of pick where they need to go. There's animation. It might tear. We'll see what happens. So model view binding, that's classically the job of the view controller. It's really mediates the interaction between the model and the view, so that's fine. Subview allocation is just views. It doesn't. Our controller shouldn't worry about that. Let's put that in the view section. Fetching data. This I also actually think is fine to leave here. There's an argument to be made to push it down to the model, depending on how you want to run things. Layout is definitely a view concern. The view controller should have no idea what layout's being used. And so that one definitely goes down. Data transformation. This one goes into the model. So this is sort of any presenters you have. You might call them view models. If you have like let's say an array of followers or something, and you need to make like some nice string for presentation that's like, Soroush and 3 other people follow you, you can use that. So that code all goes down into the model. This navigation flow, this is the big one that we're going to deal with today. That goes up into the coordinator. So that's pretty straightforward. User input can also stay down in the view controller. Its job is sort of to take touches from the user and turn them into messages for the coordinator to kind of consume. So that's going to stay. And this last one, model mutation, goes up to the coordinator as well for some very specific reasons that we can go into a little bit later. And if I miss them, come find me after. I will help explain why model mutation should go up. So this is sort of the breakdown we get, and that's not so bad. Everything kind of has like a little place to live. It's not exactly single responsibility, but we get a lot closer than we were before. So now that we know what a coordinator does, let's talk about how to make one. This is the part of the code, the talk with a ton of code. I'm going to highlight the parts that you need to pay attention to. It's also blown up really big, and Swift is pretty terse, so it might end up okay, but let's just go on this wild ride together. So cool. So this is your AppDelegate. Everybody loves this method. Everybody's familiar with this method. This is sort of some boilerplate that you need to do to set up your app programmatically. If you like to use storyboards or Zibs, you are, well, if you're using segues, you're not going to be using coordinators because those manage your flow for you. But if you are using like single view controllers, storyboards, or Zibs, you don't need to do this stuff, but in our case, we do. So we need to set up a window, we need to set up a navigation controller and set that as our root view controller. Then we need to create our app coordinator, and we'll go into what creating an app coordinator entails. Pass it all the relevant view controllers that it needs to work with, and then call start on it. The separation between creation and actually kicking off the process, to me, is important because it means that you can create this thing greedily, you can create it lazily, you can create it whenever you want, but it doesn't actually start working until you tell it to start working. This only really sets up the properties. And then last but not least, a little bit more boilerplate. Tell the window to be key invisible to actually put it on the screen, and we are good to go. There's a couple of other ways you can organize this, like you can pass the window directly to this and have this create the navigation controller. Those are small details. If you like it better that way, there's reasons you can do it that way, especially if you just swap out the root view controller. But this is the basic setup. Cool. So we've got this app coordinator. What goes in here? Our initializer is pretty straightforward. We know we're going to need to hold on to a navigation controller. We got to get that and hold on to it. And let's look at some more fun methods on it. So this is the start method that we called earlier. This is where all of the magic begins to happen. When you call the start method, immediately decisions are being made, right? And this is really important. Before, this code had to live in the view controller or the AppDelegate somewhere, right? This code, like, there was no place that decided, okay, what view controller should come on the screen next. Now that logic has a place to live. So we check if we're logged in. In this particular case, we're going to follow the logged out flow so we can show authentication. And yeah, so this decision gets made and we go into the show authentication method, which we're also going to take a look at. So this is our first child coordinator, right? So when we call show authentication, first thing we need to do is create a new coordinator. The reason for this is that I like to keep my coordinator small and focused. They don't have to be tiny, but especially if you know you're going to reuse it. So for example, authentication, sometimes you'll have an app where you can sign in from the very beginning, or you can like kind of explore some content and then sign in later. That would be a reason that you would want to use that flow in two places. And so you want to separate that out into a reusable coordinator. Again, it's going to need access to the navigation controller, so we're going to go ahead and pass it that. This is the same navigation controller we created earlier. And then we set up our delegate. So pretty much all the communication through the coordinator stacks and through the view controller stacks is done with delegates. I personally like delegates because they give you like a lot of control. They give you good semantics, like you can put words in describing how you use them, and they give you good type information. If you don't like delegates, you could squeeze a signal in here and like have them subscribe to each other. I haven't really messed with that, but I think it would work. So if somebody plays with that and makes it work, definitely come talk to me. But I chose to use delegates for this. I also left in a semicolon from when this was Objective-C code. So that's a little vestigial semicolon for you. And then you can call start on it in the same way that you would call start on your app coordinator. Now, what about this? When this method finishes, this is going to deallocate. And if this deallocates, then it won't be able to do any of the work that it needs to be able to do. So we have to hold on to it somehow. I'm gonna switch to Objective-C code. So shield your eyes. Just yes. Just to make it clear what class you're in, just so you remember as the viewer what class we're in. Normally I would... Oh, sorry, this should be coordinator. This should be app coordinator. That's my bad. Sorry. That should be app coordinator, not AppDelegate. I'll have to fix that. But yeah, so we need to hold on to the auth coordinator so that it doesn't deallocate. Right, so I'm going to show you a little bit of Objective-C code. Shield your eyes. This is, not for children. Cool. So the way we did this in Objective-C is we had an array of child coordinators, and arrays in Objective-C, you could just add whatever you want. Just put anything you want in there. It's fine. We'll deal with it. You can't do this in Swift anymore, especially because we're going to need to be able to remove them later. And to remove them, you need to know which one it is. So you need to implement equality. If you implement equatable, then you can't just put things, you can't refer to them. It gets complicated, it gets messy. So we really can't do the array method with this. You can kind of fake it with an NS array. from Swift, but the thing I actually like to do is a little bit simpler, and it's to just use a dictionary to hold on to all the child coordinators and give them all a name. Now, in this case, I'm using a string, but if you're uncomfortable with strings, you can make it an enum, so you only have the ones that you sort of set out up front. And the other option for this is there's usually not that many coordinators that are children of any given coordinator. Usually it's only 2, maybe 3. If it's a tab bar coordinator, yes.
Can't you use an array and use protocols? Your coordinators
Right. So if you use a protocol, then your protocol has to conform to equatable so that you know which one you have. And that's not going to be, you're not going to be able to just put that into an array. You can do other weird stuff, like you can try to do some kind of pointer matching, but then you have to bind the protocol to be class bound. It's just like, don't mess with pointers. Just do this. It can work. You can make it work. You can also just use an NS array from Swift and it'll work fine. But this is a lot easier. And the other thing is, like, usually you're not even going to have that many coordinators that many child coordinators. So just make a property for it, make it optional, and just like hold on to it. It's not that big of a deal. I've done this in apps. It works out okay. It's really not that many more lines of code, and it's like fine. Yeah. So that basically, now we've set up this auth coordinator, and we've called start on it, so it's going to start doing work, and we've held on to it so it won't accidentally deallocate from under us. We need to take a look at what the auth coordinator looks like. Okay. So, before we do that, we need to take a look at what that delegate message looks like. So the auth coordinator's only delegate message is did authenticate. This time I got it right. Nice. The only message here is did authenticate. And the only thing we care about is, like, did this work or not? And you're not allowed to come back until it worked. So what we do then is we kind of just nil out the coordinator so that it's not doing any extra work, not responding to any notifications that are floating around. And then we can call show content, which is that method from earlier. Yeah, so that's not too bad. Let's take a look at what the auth coordinator looks like. Are we? Oh no, I need to step through this line by line. Look at that. Great. Cool. Auth coordinator. We went too fast. Great. Yeah, so this initializer looks a lot like the other initializer. We need a navigation controller. We need to initialize it with navigation controller. Nothing crazy here. When we call the start, that's when we finally get to actually work with view controllers. So we call the start method, and this is the thing again that kicks off the whole process of, like, how this coordinator works. So the first run view controller, imagine this is like a screen that comes up that, like, gives you 2 buttons. It's like either like login or sign up, right? Like, so the user can decide if they already have an account or whatever. So this is going to be the first view controller we show. We initialize one, again, pass it any dependencies that it's going to need, and then that's ready to go. We can set ourselves the delegate to it so that we can get messages about how it changes. Again, vestigial Objective-C semicolon. And then we can finally call push view controller from it. So we're good. The view controllers no longer call this method. This method is only called by coordinators, right? Same deal with present, present view controller, the modal presentation. The view controllers no longer have to touch this stuff. They just send a delegate message and say, hey, I'm done. Let me know when the next thing, or like just do the next thing, whatever it is. And we have a delegate from that first run view controller. And so it's got 2 options, right? You can either tap the sign up button or you can tap the login button. Let's take a look at what it looks like to tap the sign up button. It'll sort of get passed back as a property, typical delegate stuff. And here again, we create another view controller, again, pass the dependencies it needs, become its delegate. Pretty boring. And then push the view controller on again, also pretty boring. Then the user keeps tapping away. They put in their username, they put in the password they want, and they tap the sign up button. That's another user action that gets bubbled up to the coordinator. And so we're back in the auth coordinator, and it now gets to do the work. So this is a method that uses promises. If you don't know promises, they're really cool. I recommend them, but it's we'll walk through it step by step. Cool. So this is the message it gets back. So this is the data from its view controllers, or yeah, from its like labels and text fields and stuff. The view controller no longer does what I call the model mutation, the API calls, the writing to the database, that stuff. And the reason is that there may be other flow steps that you need to add, right? Like let's say something comes down from the product team. They say, we actually want you to collect a picture as well from another view controller before they're actually allowed to sign up. If that happened, then all of a sudden now you have to change the sign up view controller, which was originally responsible for collecting this username and password, to change its flow so that you can add another view controller. And to me, I think that's a big no-no. The sign up view controller is what it is. And it isn't changing at all. The only thing that should be changing is the coordinator, and it will add one more step in there to like grab the image. So that's why I like to keep the actual editing of data in the coordinator. This breakdown ends up being really useful. So cool. So we create a user gateway, which is responsibilities to talk to the user API. Call sign up with an email and password. It returns a promise. On that promise, we can call the then method. Actually, we're going to call the catch method first because we can deal with that. A little bit easier. Catch is called whenever there's an error of any kind from a promise. And so we can actually send a message back down to the view controller because we have a reference to it. And we can tell it what to do and how to present that error. If it's a UI alert controller, we might want to just present it ourselves on top of it. Like we have that power. But if you need to like highlight one of the text fields and say, hey, your username was not long enough, the sign up view controller has the functionality to do that. It's just activated sort of by the coordinator. And then sort of the happy path, then is kind of like a completion block to any asynchronous activity with the promise. And so we'll get some sign up result, which we're actually going to ignore. And we'll call our delegate method, and that message will go back up to the app coordinator, back to this code that we wrote earlier. Which will nil out the auth coordinator because it's now done. It's done all of its work and we don't want it to exist anymore. Nil it out, it gets deallocated and show content and so on and so forth, etc. That's basically like what it looks like to build a flow out of coordinators. You're adding an extra step in there. You're adding a step of, okay, instead of the view controllers manually pushing each other on, but when you add that step, you get a lot more flexibility. And so I want to talk about some of that flexibility as we kind of wind this thing down. Why do I think coordinators are great? There are 5 reasons for this. Number 1, it isolates your view controllers. The whole reason that this entire thing happened was I needed a login view controller for an extension I was building for an app that already existed, right? We're building an app extension. I needed the login flow. So I pulled in the login view controller, which pulled in the API, which pulled in a bunch of model classes, which pulled in literally 3/4 of the app got pulled in just from one import. And every view controller that touches every view controller that follows it needed to, it all needed to kind of work together, and it was all dependent on each other. And so it was really problematic, the fact that I had to import all these things that I didn't need. And so I wanted more of a tree-like structure rather than a crazy graph going everywhere. So a nicer way of thinking about it is if you have your view controllers normally like this, A pushes B, B pushes C, A has an implicit dependency on D, even though it wouldn't look like it when you look at A. Because all A does is it knows about B. But to get to B, you also need to import C. To get to C, you also need to import D. And so you can't pull in just A anymore. You have to pull in all of these. And if you have more view controllers than that, they're all coming with you. What the coordinator does is by isolating those, they now each live in their own world. And maybe they have things they collaborate with, etc. But they don't have to touch any of the other view controllers. So if I want to pull in view controller A to some other project, I can easily do that. Likewise with any of the other ones. So that's the number 1 big thing I love about view controllers is they're isolated. Number 2, in the isolation, they also become reusable. Let's say you want to A/B test a new login flow. The product people have it set up for you. Some of the view controllers are the same, but some of them are different, and they only want to roll it out to 5% of users. What are you going to do? If you had it, let's say the old way, so you had, let's say, your first run view controller that pushes on the old sign up, you now have to have an extra property over here to tell it to push the new sign up in certain cases. So now your view controllers know about your A/B testing, and they're like calling conditionals to do different things. And it's like, I really just want to reuse the first run view controller without having to bring on the extra baggage that it normally comes with. So you get this reusability element when you use coordinators. So view controllers, they become like normal objects that you can actually use and reuse, and it becomes kind of nice. When you work with coordinators, you can take your tasks and bundle them up into a thing, right? Before, the way we had, like, let's say that Instagram thing where you take a picture and then you straighten it and then you add a filter and whatever. If you ever want to use that again, you really can't. All you can do is like present the first one again and hope the flow goes the way that you expect it to and hope that you have all those dependencies that you need. But now you have like one object that represents one encapsulated flow, and you can say, I want to use this again. And this thing knows what dependencies it needs, and it can be initialized with all that stuff, and you are good to go. This is a little bit more abstract, but really good, but very useful, yeah. And yeah, cool. So sort of the same point of the model mutation that I brought up earlier. Display binding, which is a very important and useful part of view controllers, keep those models and views separate from each other, is important, but doing the side effects is not necessarily important. I want to know that if I'm going to reuse a view controller, that when I like present it on screen, it's not going to be able to delete something of the users. Like, I want to be able to know that when I use this view controller, I'm just getting its good looks rather than like all the baggage that comes with it. This is sort of like the command query separation, which is this idea from computer science that if you are just getting some information, it shouldn't change anything. Like, you should be able to get the thing over and over again without worrying about if you're secretly changing it under the hood. It gives me a little bit more sanity when I'm working with this, with code like this, so I really appreciate that part of it. And the last bit is that coordinators are totally in your control, right? So you wrote them, you know how they work. They tell your app how to work instead of your app telling your other code what to do. You tell UIKit what should go where and what should happen at what points. Yeah, so this is an app that I wrote a little while ago. This is a sort of an example of a tree of coordinators that exist in this app. For example, if the user was creating a message, these two coordinators would kind of be inactive, and this one would sort of be the active one. Or you could be kind of in a different flow of the app when you're like creating an account. You could be choosing an image while you're creating your profile, while you're authenticating, while you're in the app. So yeah, so that's kind of an example of like how, this is an admittedly pretty simple app, but this is sort of how it might look. These don't really exist yet, but they can exist in the future, right? Yeah, so that is pretty much all I have for y'all. That's coordinators in a nutshell. I really appreciate y'all having me out here. Definitely find me afterwards if you have questions or if you want to talk about any of this. And again, I really appreciate coming out to Stockholm. Thank you.
Thank you so much, Soroush.
Yeah,
I think this was a great talk, giving all of the positive benefits you get from coordinators and also encapsulating everything that gets into actually implementing it.
Yeah, they've been pretty nice to work with over the past year and a half. So yeah, I recommend it.
Cool. So we actually have time for questions from the audience.
Yeah,
so if you have any questions, please raise your hand.
Oh. One over there.
Hi, thank you for the talk.
Yeah, absolutely.
Is there any chance that you run into massive coordinator problems, especially if you have a view controller that is supposed to, like a screen, I'm sorry, that they're supposed to do a lot of things, and how do you avoid that?
Yeah, it can happen. The nice thing is if you usually limit, your coordinator is limited to two things, right? It's limited to the flow, which is really just instantiating view controllers, kind of with sort of factories, and then presenting those view controllers. And then it also does this model mutation stuff. And usually that stuff I tuck away in some kind of I use the user gateway, or I use some other object that really just exposes a method that, or a message that you can use to do the thing. So all you're really doing is creating view controllers. A little bit of other stuff, but for the most part, the bulk of the lines of code is creating view controllers. So it doesn't end up getting too big in practice, especially if you're good about keeping the model mutation in other collaborators and other classes. When there was one app we converted to coordinators, and the first step was, instead of trying to break out into child coordinators and figure that stuff out, we just moved all of the navigation code from the various, there was 20, 25 view controllers, all up into one huge coordinator. That was the first step. And we broke it out later, but we were this is better than what we have. Let's code review this and commit it, and we'll be in good shape. And it ended up being 1,000 lines of code. Really not that bad. So even a massive coordinator, it's not so bad. We did end up eventually folding those out. I think the longest one is now 300 or 400 lines. It's not horrible. So, yeah.
Question over here.
Yep.
Question is, I personally don't use Segways, but for those who use Segways, does this coordinator might introduce some sort of issue in terms of navigation?
Right. Yeah, so there's a fundamental conflict between coordinators and Segways because they both want to do the same thing for you. They both want to guide your user's flow. The reason that I like coordinators better is because it's code. So you can do conditionals, you can do any kind of branching or anything like that. You can actually do here. Whereas with Segways, you're stuck with what you have. And then you can create Segways and call them programmatically, but I don't think they're very good. The other problem is your segue requires knowledge of the whole graph of all of your view controllers, whereas this only requires, let's say your the choose image coordinator that we talked about at the bottom. This touches 3 view controllers ever. It touches you got to pick one, you got to crop it, and you got to actually post it or whatever. So this coordinator doesn't know anything about this stuff, which is nice. Whereas if you use Segways, you have to basically put all of your app into one big storyboard. I know there's storyboard references, but ultimately it's still one big graph, right? And so all of your Segways know about all your other Segways. None of them are reusable. Can't bring them across the different apps, can't bring them across the different extensions, stuff like that. So for me, they're not really a solution to the problem. If they work for you, that's good. You don't need any of this stuff. But for me, they haven't cut it in the past. So that's why this exists. Cool, we got one back here.
Yeah, this is mostly a naming question. The name coordinator, how is it different from the router design pattern? Is it just a router or is it a little bit more than that? Or
yeah. The naming is interesting. Sort of the behind the scenes on this is I don't know, I went back and forth on a bunch of stuff. I tried workflow, I tried process. Somebody was telling me they use something they call directors to do sort of a similar thing. I landed on coordinator because it felt like that's what it was doing at a high level. And router didn't work for me because of the model mutation stuff. Your router should really be responsible for putting pieces in place. The other thing that went on with that was we had a router at the company that I was working for at the time, and its job was to take a URL and parse it and turn it into a route, which would be kind of a snapshot of view controllers that it would then present, right? So if you tapped on a push notification, you would get a URL, and this thing was responsible for turning that URL into a state for the app to be in. And so I couldn't reuse that name, so coordinators. Yeah. Yeah, cool.
Yep.
What's up?
So how would you use a coordinator to react to something which isn't a user action? So in the problem domain that I'm used to, which is VoIP apps, the user could be called at any point without them doing anything themselves, and
right.
you have to react to that to present the calling screen. And the place that the user was at could either recover from that and get back to it when the call is over or not, depending on where it is.
Yeah.
So it's sort of a tricky user interface scenario.
Yeah. It's funny. I was talking with some of the Reptel folks earlier today, and they're very it's a very similar problem. We talked about this exact thing. The answer that I have on this is that essentially what you have is you have some state without coordinators. You have some state of view controllers that the user is in, and you have some state that you want to be in. Whether that's from a push notification, whether that's from a call that came in. Whether that's from some data that came through from Pusher or Firebase or whatever, your goal is to merge this state into something that's sensible, right? And so you have to resolve those conflicts when you merge these two states. So whatever you're doing for your view controllers, do that here too, basically. You have to resolve that state for your view controllers anyway. Usually that's just tear everything down and then just put in the one I want. If you're doing that, that's really easy to do. If you're manually walking over it to figure out what the state should be in, you can manually walk over this tree instead and then tell these things to reconfigure their own internal state and their own internal navigation controllers. It's that is a very tricky place to be at with this stuff. But it exists for both sort of trees, whether you're working with view controllers directly or whether you're working with them through coordinators. Yeah. Got one more over here.
Oh, have you thought of somehow unit testing this? It looks like a nice way of validating the flow of your app, and somebody doesn't screw up stuff. But from what I saw, you are modifying internal states and then only working with private properties. So do you have a way to unit test this or validate that it's always the same
Yeah,
thing?
absolutely. Usually, I don't bother unit testing this stuff because I'm a terrible programmer. I tend to unit test stuff that's more data in, data out, very logic heavy. That being said, if you have logic in this, like your branching logic of like, hey, is the user logged in or not, you can create a navigation controller, inject it into this coordinator, right? Tell it to start the process and like set up, pass it whatever, dependencies. Let's say it needs to check an auth token before it knows if it's logged in. You pass that in as well as a mock, and then call start and then check the state of the navigation controller. It can be done. People have done it. Friends of mine that have worked with this stuff have done it. It works. I've done it in a couple of edge cases. It's definitely easier to unit test than the old way, which is like you not only have to pass all the dependencies through sort of, you have to pass any dependency that your controller D needs, you need to pass it through A, B, C, and D if you're doing like initializer-based DI. So that part of it gets messy if you're trying to test it the old way. Testing the like every single sort of switching thing, like whether it's iPad or iPhone or whether it's A/B testing, that needs to be passed in as a dependency so you can control it. It's harder with this. It's easier with this. If it comes. Come on. Did I even push the button? How about now? Is it frozen? What's going on here? That really just destroyed the whole punchline. Anyway, there it is. Yeah. So I would say it's easier with this. If you want to do it, I would say do it. I wouldn't want to do it the other way. Yeah.
So we can have one last question.
There's like one here.
Stream and videos.
Would you have your coordinators manage the system view controller? So, for example, our alert controller or Apple Pay or anything like that, or would you just leave those to the view controllers?
It's a bit of a blurry line. I would generally say if it's a new context, coordinator. So sometimes you have a view controller that has many child coordinators, and I feel like those are really logical children of the view controller that you're working with. So that's like kind of fine to leave to the view controllers. But if you're presenting a UI alert controller, if you're definitely presenting Apple Pay, that stuff, I would absolutely pass that through the coordinator stuff. That might make it harder to test. To the point of the question of the gentleman in the back, but definitely, I would say like if it's a new context, brand new, or pass it through the coordinator rather than trying to like let the view controller handle it. Yeah.
All right. So thank you very much for a great QA session and presentation.